In this video we're going to add two sine waves and express the resultant in the form of r sine theta plus alpha. We've got V1, which is 2 units long, so it's 2 sine omega t. V2 is 3 units long, it has an amplitude of 3 and a phase shift of plus 45 degrees, so it's leading V1. V3 is equal to V1 plus V2, and we're going to express V3 in the form of r sine omega t plus alpha. We're going to do it with the graphical method first. So there's where we're going to put our graph, and I've written on V1, which is 2 units long with no phase shift, the black line. V2 is 3 units long at an angle of 45 degrees, so you need to make sure you use your ruler to measure them and make the angle with a protractor. V3 is the diagonal of the parallelogram. R is its length and its amplitude, and alpha is the phase shift. We need to measure V3's length, which is r, and we need to measure alpha, which is V3's phase shift. So from measurement, if we drew it correctly, r was 4.64 units using the same scale, and alpha was 27.24 degrees. V1 plus V2, which is equal to V3, we can say it's 4.64 times the sine of omega t plus 27.24 degrees. So that's the graphical method. We're going to do the mathematical or trigonometrical method with the same numbers. V1 is 2 sine omega t. We're going to leave that be for now, keep it to one side for later. We're going to use the compound angle formula on V2. So let A be omega t and let B be 45 degrees, and the compound angle formula sine A plus B is sine A cos B plus cos A sine B. A is omega t and B is 45 degrees. So for V2, it's 3 lots of sine omega t times cos 45 degrees plus cos omega t times sine of 45 degrees. That's 3 lots of sine omega t times 0.707, which is the cos of 45, plus cos omega t times 0.707, which is the sine of 45 degrees. Use your calculator in degrees mode. Then multiply out the big bracket. V2 is equal to 2.121 sine omega t plus 2.121 cos omega t, because 3 lots of 0.707 is 2.121. Now we're going to add V1 back in. So V1 plus V2 is 2 sine omega t plus 2.1 sine omega t from V2 plus 2.121 cos omega t from V2. Add the sine components together. V3 is equal to 4.121 sine omega t plus 2.121 cos omega t. So r, which is V3's amplitude, we work out by the square root of the sine coefficient squared added to the cosine coefficient squared. So r will come out at 4.635, that's its amplitude of voltage 3. Scroll down a bit. To find alpha, which is V3's phase shift, what we do is tan to the minus 1 of the cosine coefficient of V3 divided by the sine coefficient of V3. And that is equal to 27.23 degrees. So we can say V1 plus V2, which is V3, is equal to r sine omega t plus alpha, which is 4.635 sine omega t plus 27.23 degrees, which is very similar to what we did graphically, but this is more accurate. If we look at the graphical method, it was similar, but we can't be as accurate. So hopefully this will help us with the r sine theta plus alpha questions.